I know we are 4 minutes late, so apologies. I think we are good for now. Welcome everyone to Thought Leadership Panel on Autonomous Surgery Using Robotics and AI, Reality or Myth. As technology pushes the boundaries of medicine, we are faced with a provocative question. Can machines truly perform surgeries without human hands? Or is it still a science fiction? Hi, this is Pankaj Gupta from Adhav Venture Partners. We are a zero BS revenue scaler and fund based out of Singapore with approximately 120 startups in our portfolio. Today, we will explore the breakthroughs, the barriers, and the ethical dilemma shaping this frontier technology. Thanks to the diverse expert panelists who will help us separate the hype from the real promise of autonomous surgical systems. To start the introductions, I will request our esteemed panelists to introduce themselves. Richard, if I may request you to do a quick intro, please. Richard.
Thank you so much, Pankaj. Well, my name is Ruchi Dasselaar. I'm a digital transformation and strategy leader. Next to that, I'm a chair for the AI and cardiology group for the ISFTH in collaboration with the World Health Organization. I recently founded Global Advisory Digital, where we support companies go to adopt the digital pathways via AI. And that's basically in a very summary it. Thank you, Pankaj.
Thank you. Thanks a lot, Richard. So a lot of AI that you are looking at right now, and I know Richard didn't mention, but he's also writing a lot of social media or digital media channels, and he's also appearing on different news channels to express his opinion on AI and new technology. So thanks a lot, Richard, for being part of the
You're very welcome.
session today. Dr. Amit, may I request you to go next, please?
Hello, everyone. So I'm Dr. Amit Sharma. I'm an orthopedic spine surgeon. I'm based at Mumbai, South Mumbai to be precise. I was trained at KEM Hospital in Mumbai, and then I was in US for 3 years for my spine fellowship trainings. And I'm practicing in Mumbai since 2011. So I pretty much do all kinds of spine surgery, we do have some experience about navigations and robotics. So I mean, that's what my primary interest is in this meeting. Thank you.
Thanks a lot, Dr. Amit. And Dr. Amit has done more than 3,000 surgeries in different parts of the world, and he's associated with some really highly respected hospitals in India. So really appreciate your time, Dr. Amit. Erez, may I request you to go next, please?
Thank you, Pankaj. Thank you for inviting me and for arranging that panel. So my name is Erez Lampert. I'm from Israel, engineer. In my background, I started my career in the Israeli aerospace, missiles and satellites launches, where accuracy tracking was critical. Later, I took the tracking and accuracy and imaging into the medical field and basically led the development of the iTero element, which is the leading 3D dental scanner today in the world, working for Invisalign. And 8 years ago, I joined forces with a professor from the Israel Hebrew University and Hadassah Hospital, Professor Josh Roder, to build an optical AI imaging solution and navigation for spinal and orthopedic surgery. Looking forward to talking more about that today.
Thanks a lot, Erez. So from missiles to spine surgery, that's an amazing transition. Appreciate your time today. Dr. Ruchi, may I request you to go next, please?
Hi, my name is Dr. Ruchi Das. I'm a clinician turned healthcare entrepreneur. Responsible AI is very central to me because we use it every single day. And all the companies that I've worked for or have invested in use AI in some shape or form. Recently, I wrote a paper on AI policy in global health, which talks about responsible AI and ethics around AI, highly cited with IEEE, Springer, and some of the known names. So yeah, here I am to contribute to the panel, and thank you for having me.
Thanks a lot, Dr. Ruchi. She has also done 3 exits in the startup ecosystem, and she's a very strong angel investor into the ecosystem. So thanks a lot, Dr. Ruchi, for your time today. Dr. Swapnil, please.
I'm Dr. Swapnil. I'm a neuro and spine surgeon. Right now, I'm working in Nanded in my own hospital. It's like 100-bed hospital in Maharashtra. I've worked previously in US at different institutes like MSKCC, then Yale University and USC Chicago for a couple of years. Yeah, I started my own practice in 2014. Yeah, I'm still since last 10, 12 years I'm in Nanded. Yeah.
Thanks a lot, Dr. Swapnil. So other than being a neurosurgeon, he's also an entrepreneur. He moved from US to Nanded, and he has been running his own hospital for the last 10 years or so. So really glad to have you here, Dr. Swapnil. Now it's time to get into the real panel discussion and get some real hot sizzling insights from the experts. And on the very first question, I would like to get insights from Erez and Dr. Ahmed. And it's I'm not asking questions whether robotics, AI, 3D imaging systems are going to replace surgeons or not. I think we all agree that they are not going to completely replace surgeons. The question is, how can these systems enhance human intuition and precision in the operating room? And why I'm asking this question, because when you talk to different healthcare leaders, you hear that, hey, surgery is not art or not science. It's combination of art and science, right? And a lot of experience, intuition is also involved in doing the real surgeries. So Dr. Amit, would you like to lead the question, please?
Yeah, so like as a spine surgeon, as I told you, like my interaction with AI is primarily when it comes to navigation and robotics. So one of the main field where we use AI is to put those pedicle screws, whenever we are trying to do a complex pathology, and we are trying to do minimally invasive surgery where we are not able to see inside the patient. We are just kind of working on the surface. We are trying to reach the inside. So based on these AI models, we kind of try to reach that inner part of interest without actually going into it. Now, so that's our primary area of interaction with the AI. To some extent, I think we also deal with the AI when it in the reporting what we get from the radiologist. So and I think that's a big thing which is coming nowadays, that AI based radiology reporting. So many times when I see MRIs, CT scans, I see that a lot of problems which are there on the MRI imaging are missing in the report. And sometimes I had to kind of call the radiologist and ask them to include that, especially like pars interarticular fracture, which is many times missed by the radiology reporting. So these things I think definitely will be kind of taken care of by AI. In the operating room per se, like as I told, like it's primarily the pedicle screw system, which like to some extent we do use. Now, having said that, the penetration of these technologies in India is not that widespread. So we don't deal it, like I go to few hospitals, different hospitals, and maybe one or two hospitals have these, like high-end gadgets to help the surgeons. At other places, we have to use our common sense and like surgical skills, which we have learned over the period of years. For me, AI is not artificial intelligence; it's augmented intelligence. Like it should support you to whatever you're doing. One other thing which I see is that and I think it's something which need to be looked into, that as long as we are dealing with the normal situations, AI might help because it has attuned to that system of a particular process. But when the things go out of the ordinary. So the other thing where the robotics are frequently used is knee replacement surgery, and it is like every person is now a robotic knee replacement surgeon. So as long as knee is a little bit into varus, some arthritic changes are there things are okay. But what about when knee is severely deformed?
is the AI going to, recently there was a Australian registry data with more than 1 lakh patients, kind of, like where robotics were used, and they didn't find any significant difference in terms of the outcome. So ultimately, whatever we are doing, it should reflect in terms of the better patient's outcome, better patient recovery, and better surgical outcomes for that matter. So if we are able to achieve these aims, better patient outcome, faster recovery, they are going home faster, post-operative pain is less, we don't have to dissect much while doing the surgery to achieve the same job which like we would have done otherwise by doing an open extensive surgery. So if we can achieve all those things, AI is good. If we are able to achieve these things in a regular case where we could have done the case in a routine fashion also, AI just kind of like worked as a video game for us. It's not going to add any significant benefit, especially if it comes at a very like significantly added cost. And the cost is not only one time. It's like whenever you take a machine, it's the cost of purchase, cost of CMC, and the maintenance cost, and the cost of the usables, like those disposable things, which every time you have to use with robots, surgeries, or markers if you are dealing with the medical school system. So we have to look into all these things that it should be scalable. It should reach. It should not be available at some of the elite centers in the South Mumbai. It should be available in the Nanded also. Dr. Swapnil Adhav also should be able to have one in his hospital. Then that will be the penetration of the AI.
Right. Yeah. No, that's interesting take. So from your perspective, AI is augmented intelligence, and the clear ROI, the clear quantified value proposition has to be there before the adoption happens. If it is not there, then you can't be having a widespread adoption. Appreciate that, Dr. Amit. Erez, so you are the innovator. You have been into R&D space for quite some time. What is your perspective on this? What do you think?
Right. So first of all, I completely agree with Dr. Sharma. The current solution today, he called them expensive gadgets. So they're probably not as good as they should be. I came from the dental world, and we saw that in the beginning with the dental world. And I think you can look back at phones 20 years ago, and you'll see that's the same thing. Technology, when it starts, it's usually not mature enough. It's usually an expensive gadget, and it requires innovators and far-leading leaders in the industry. It could be dentistry, it could be spine, it could be just people like us using phones to see the future and see where technology can go. And I completely agree, in spine orthopedics, the technology is not exactly there. Even Intuitive Surgical, a $100 billion company, people are saying that the clinical results are not significantly better than when humans use them. And in the end, as Dr. Sharma said, it's all about the patient. We want the patients to be healthier and better. Unfortunately, we have to think about economics as well, how much it costs us, and so on. But in the end, it's all about the patient and the patient outcomes. Now, so leaving the, I would say, not great today or present, let's look about surgery in a more general way. Surgeons, when they go into the surgery room, they use many years of experience and learning to handle uncertainties. As Dr. Sharma said, when surgery works on a normal knee, on a normal spine, it could be easier, AI could handle it. But unfortunately, it's not the healthy patients that come to be treated, it's patients that has issues, right? So it's more often than not that you have to handle the not normal, the sick. Of course, that's a normal way. So when surgeons go into the surgery room, they face uncertainty. They have limited data, they have limited information, and they have to use their experience and knowledge and intuition to find the best way to treat the patient. Our goal, or the future of AI, is to augment those surgeons. So there are stuff that computers can do better than humans. The simplest one is measurements. Computers and cameras can measure things very, very accurately, and humans needs to estimate. So the first thing I would expect AI to do, and you see that in radiology a lot, but we want to bring that into the real-time surgical scene. We want to see measurements. We want to see the measurement that the surgeons want to see, and we want to see them in real time for the surgeon. Another thing an AI can do, a computer can do better than humans, is look at many things at the same time. So we as humans focus on one thing and we might lose sight of another thing. Computer can look at 10 things at the same time. And even if each look is not as smart as the surgeon, they can guide and give feedback if the surgeon is missing some information. So together, computer can bring added value to the surgeon, not replace them. As you said, we will augment the surgeon. It's like, a fighter pilot having a lot of data coming to him from the screen, from the sensors. A fighter pilot can look down and see how far he is from the ground, but it's better to have this number jumping to know exactly where they are and so on. And so we want an AI system that will look together with the surgeon, analyze, measure, give direct and actionable feedback in real time for the surgeon, for knee surgery, for spinal surgery, and basically for any type of surgery.
So from your perspective, Erez, in the ideal world, we should be able to combine best of both the worlds. So obviously doctors' intuition, doctors' experience combined with the computation capabilities or vision capabilities of the AI or of the robot. That's how you want to merge these two and create the ideal world in the surgical space.
Exactly. I don't think exactly. Thank you.
Fantastic. I'll be moving on to the next question now. And this question is for Richard, Dr. Swapnil, and Dr. Ruchi. And think about a scenario where you have created a lot of database and now your operation room or operating room is creating a lot of this data set, right? And based on that, you are building AI models, you are building AI systems. But the question is, who takes the lead, who takes the charge? Whose decision is being prioritized, whether it is surgeon's decision that you prioritize or AI's decision that you prioritize, right? So in a way, how much power you are giving to the AI system compared to the doctor, right? And then, the bigger question is, if something goes wrong, and it's the human tendency, when something goes wrong, we, come out with a worst sort of persona, right? So if something goes wrong, who takes the blame? Whether it is the surgeon who takes the blame or it is the manufacturer of that AI robotic system who takes the blame, right? So I'll start with Dr. Ruchi first, and then take it from there. Dr. Ruchi, please.
Yeah, Pankaj, I think you're right. Operation room is fast becoming a data ecosystem. You talk about multiple sensors, real-time analytics, perfusion data, vision AI, and even all the clinical decision support playing at the same time. I believe the challenge is not technical, it's epistemic. Basically, whose judgment prevails when human intuition and algorithmic output differ, right? My view is accountability in the OR room must follow the same thing as in aviation, like Erez said. Human in command, AI in the loop, right? So the system can recommend me, warn me, and even act autonomously, in a predefined envelope. But ultimate authority always resides with the licensed professional. And I'll probably come to that, why it should reside with the licensed professional. I believe every system should be designed with reversible autonomy. Basically, AI-driven action must have a documented way for a surgeon to override, to question and ask for justification, and to pause it. And this override should be frictionless, right? So when we design our systems, there is a design time, right? When we train the models, right? So we train AI models on transparent, auditable data sets. That's step number one. The second step, which is a runtime, is you should have a human override architecture, which I just said that if they are in conflict, you take over as a surgeon. And the third one is performance logs, so something that we review at M&Ms with algorithmic decisions reconstructed as and when needed. So we don't have to become a slave to the algorithm, but the algorithm kind of becomes a codified apprentice to me. I think that would be a real world scenario for me. And in my operation theater, robots can make suggestions, but it will need my permission slip to act. that's the that's the ideal atmosphere for me. The second question that you asked is who takes the blame? So until the tort law catches up, courts and insurance still feel that surgeons and institutions are the one who take ultimate responsibility for anything that goes wrong, right? It's clinical negligence, malpractice. And it depends on whether the clinician didn't act and maintain the standard of care, the clinician didn't question and let an autonomous action happen, or didn't supervise it enough. And basis that, we end in a soup. So I think until robots starts paying for the malpractice claims, it's my name in the consent form.
Okay, so that's interesting. So you want final authority and blame to be with the surgeon, right?
Yeah, I think rather than saying blame, I think it would say that where the responsibility, where the responsibility went away.
Awesome. Richard, what's your take on that? And I know that you are also looking at policies, regulations for different countries. So how do you think about it?
It's an interesting question. So I think I take this from a multi-stakeholder alignment, because I've been driving artificial intelligence to the marketplace for over the last decade, being an early adopter in 2013. And in that case, it really augmented the decision maker, in this case being the clinician or the physician. However, I'm also part of the Fortune magazine AI advisory board and council. So sometimes I get interesting use cases on the clinical impact and the economic impact. And I take that from an academic lens using Professor Porter and Kaplan at Harvard. So I'm a strategist by design, and patient outcome is patient value divided by cost. So it should be superior in the cost decision making and the clinical decision making. If you would adhere that from a policy point of view, you would immediately have a letter to file for any governing body to make sound decisions on. Because to Dr. Ruchi's point, I slightly differ. We need to use AI as a looking glass into the future. Regular AI is, of course, what we all know, ML, deep neural networks, and whatnot. But we are also facing in 4 to 5 years agentic AI. And that's indeed AI that can make informed decision makings. And this is the use case for the patient. So I lived in India, I lived in the US, lived in Africa, and we do not have skilled physicians everywhere. And where I see autonomous cardiac or orthopedic surgery is a system that can be self-supporting, because we simply do not have enough physicians around. Ultimately, what does an AI do? An AI is being agreed by an FDA or a CE marking on sensitivity, how sensitive it is, and B, specificity, so how specific it is. The best physician in its field tops at 70% efficacy, 70%. And I think from that I listened to what my uncle said during our last family birthday. And he said, my kid has outgrown us, and he's grown taller because every generation gets a little bit taller. And in that way, birth of humanity, I think AI has been conducive to what we've created as people. And I think there is a delicate balance between allowing AI to do what it does now, and that's very simply said in one word: make better decisions. Make our no's better and make our yeses better. And exactly. So it will make our economics better, but also our clinical decisions, because we're flawed. And I think the wisest thing is that to understand that we can make decisions, and it would be a next path to an autonomous system that can create true value, both economic and in human lives, in the global south and north. That would be my 2-3 minute shakedown on how to support value holders, stakeholders, and governments all alike, because we need to be conducive to better choices. And I think that's where AI is superior in.
So you're very much comfortable in giving the autonomy, authority to the AI systems, as long as they
Yes.
are properly tested, certified, licensed, and so on and so forth. And I'll have a follow-up question on this, but let me first feedback from Dr. Swapnil. But
Sure.
yeah, Dr. Swapnil, please.
Yeah. So I would lead as a surgeon. I would lead the OT. I would lead the surgery. Yeah. Whenever I will need something, which is help or something, I will definitely go for AI. Nowadays, what we use in the at least like periphery of India, we see arms like these X-ray machines, and those machines help us with different views, how to insert screws or how to insert rods in the bones. So we'll use AI for that help, but definitely I won't allow AI to do surgeries. Yeah, because many a times, we have a lot of data, we have everything, but sometimes the situations come where we get stuck. As a surgeon, I'm operating since last 20 years. But yeah, sometimes I also get stuck up. There's in few cases, we need to stop the surgeries or take another decision to insert screws at different levels rather than the levels we actually schedule or we actually thought of putting the screws. There are many unforeseen scenarios that can come. Unfortunately, the screws or the something goes out of the vertebra and may puncture the major blood vessels, and patient may die on the table. These are like unforeseen situations, and I'm not sure how much machines can handle. And yeah, taking charge of surgery by AI, no, I won't agree with that. Yeah, definitely I will take help. And yeah, every responsibility in the OT will be surgeon's responsibility. Yeah, AI will be helping the surgeon to operate. Yeah, it will definitely the navigation system will definitely decrease the time of surgery. Yeah, that will help patient to come out of anesthesia quickly, and sooner the patient will get discharged from hospital. That will decrease the cost burden on insurance as well as government or private payers. Yeah. So yeah, definitely AI will help, but AI, I don't think AI would lead. I've heard the stories. Probably Dr. Ruchi knows about this. One cardiothoracic surgeon, he is in great soup because of AI. Something happened. He couldn't. AI took over the surgery, and
Yeah, he couldn't override. Yeah.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
No, so my question to specifically Dr. Ruchi and Dr. Swapnil is, would your answer be different 5 years from now? Or, if we take, different scenarios where, let's say, there's a surgeon with 2 years of experience and supported by AI system 5 years down the line. The other scenario where the surgeon has 25 years of experience supported by the AI system. Would your answer be different in those scenarios?
So I think my answer will not be different. It could only be different if you're making it procedure specific. So to give you an example, in emergencies, AI has constantly proved to lower conversions and length of stay. In rectal cancer, it has shown to improve margins. But in cholecystectomy, the primary metric of success is BDI, where it has massively failed. So I'm happy to give it some more autonomous room in certain surgeries where it has already proved success and have improved margins on large data sets. It's like trying a new drug, right? If you have established record of least side effect and maximum outcome, you let it be. But that if there is more harm than good that can happen, then you try and control. So, and I still feel feel that, AI has a long way to go. I feel with the growth of AI, the management and the governing acts around AI are not developing that fast. So we are pretty much playing a catch-up game, whether you talk about the FDA's PCCPs or EU AI Act or the Product Liability Directive. These are all catching up, right? And when you think from a patient side, I mean, think of a patient right now. Okay, you understand as a doctor something, you're relying on a machine, but the patient is relying on you, right? So there is something called as the Montgomery law here in the UK, where you patient also have to understand what is algorithm doing, who's accountable, what it can do, cannot do, the failure modes and stuff like that. And that's so much for a patient to digest and understand. So I I might change my viewpoint in 5 years or 10 years down the lane, but if right now what I see coming is there are certain procedures for which I can rely on robotics, and they have shown themselves to be reliable. But if it is not procedure specific, I will still keep the bounded autonomy that I want.
Interesting. Dr. Swapnil, would you change your perspective 5 years down the line?
Yeah, possibly, but we have to see, I mean, how much that can help. Because surgeon with 2 years independent experience and the machine, but independent experience, before that independent experience, surgeons get like a lot of training before starting their own. And that experience, I mean, yeah, machines will learn, but will take time. Yeah.
Okay. And Richard, I think you are already very comfortable with the AI system, so you will become even more comfortable 5 years down the line, right?
I do a lot of public and non-public research on this part, and it's where we place our investments on decisive AI, yes or no. To Dr. Swapnil, if I can say Dr. Swapnil, someone who's never changed his mind, has never learned anything. I think if digitization has learned us anything, is that we're looking at a non-linear growth model, both in the economic but also in the clinical output. And with that, to your yes, I'm comfortable with AI. On that sense, if it makes a mistake, it's more hard to correct. But I think for some certain very decisive output measures, it is superior than man. And in that point of view, we're able to scale it to a broader audience. And I've been in a Stanford general practitioner session, I think 2 years ago. I think they're annual, but it takes too much time to attend them all. So we're looking, for example, to cardiology care, the first line measurement, where you use a third line. So that would be academic hospital as a line of defense. And basically, if you democratize advanced algorithms in a prognostic, so that means looking into the future, you can detect diseases earlier. And that can simplify your clinical procedures. And then sometimes the clinician says, do we have enough patients left? I think, well, there's not a shortage of patients. I think we do not have enough hands to take care of. So from an economic modeling point of view, if you can detect diseases before they happen, you flip the economic model in that same measurement, because basically that's the system that we designed. It's economics and it's clinical output. And I think if you, it's like economics. You're an economist as well. It's Q times P. It's quantity times price times people and times time. So I think if you find systems, even with clinical decision making, during your procedure, and I'll stop with one final use case on the Society for Cardiac Robotic Navigation. It's under my volunteering section, where we've used a 56 kilobyte, so the old internet modems, for remote surgery from Europe to New York on an old hotline. But imagine what you can do if you place these pods somewhere in South, I don't know, Southeast East Russia for all I care. I think we could be delivering healthcare at scale. But it's what do we want to give away as people? And there will still be a time between X and Y. But I'm confident it will be a bright future.
Yeah. So you
I see you thinking. Yeah.
Yeah. So you also answered my next question a bit. And I would
Apologies.
like to go back to that's good actually. That's a really good perspective. I would love to go back to Erez and Dr. Amit on the next question, which is more about scalability versus giving a toy to the elites, right? Erez, when you are building Pathkeeper, when you are building your own AI 3D imaging solution for the spine surgeon, what is your vision? What will be the success from your perspective? Do you want to make it accessible, create the scale for, for poorest of the poor countries and cities, or do you want to make it extremely interesting toy for the elite so that they can increase the efficiency, they can increase the outcome, accuracy, and so on and so forth? What is your vision?
Right. So it's interesting when Professor Schroeder asked my help to build this optical navigation system, he was talking about ubiquity. Everybody is able to use the technology. And we started by looking at 3D imaging and optics, something that is cheaper, more mobile, and easier to use than 3D X-ray system like an O-arm. A 3D camera doesn't cost much and can move around, while an O-arm machine that takes scans in the surgery room can cost almost $1 million and can't really move. So that was the vision. But when you really change technology, you start bringing more and more capabilities. And I like what Richard said, and this is one of the things that we started to see where AI is valuable. So maybe Dr. Ruchi, you are the best surgeon in the world, or Dr. SHARMA, and you don't need AI help. You're great, but maybe your new partner is not, a new fellow or somebody out there in the suburbia, or as you said, some remote operation, or Africa, as Richard said, some place where they don't have access. Even in the United States, in Idaho, it's not always you have expert in every subcategory of spine surgery that you have access to. When you're in Mumbai, when you're in New York, you can find somebody who is an expert in your specific spine problem. Maybe even in Boise, Idaho, it's not just South or North or APAC or whatever. Everywhere there are places where they're a bit more remote and you have less experts. Everywhere you have young upcoming surgeons that have access to, that needs to treat people and are not experts. By using AI, you can do exactly that. You can augment them, and not just augment them by making a decision for them, but also augment them by allowing this very efficient way to transfer data. So you have a new fellow, Dr. Sharma, he goes to some place outside of Mumbai, and now using AI, using 3D imaging, you can get the information from his surgery room or her surgery room into your eyes, into your office, and you can guide them in real time. So that's a different level of augmentation just by connecting things from afar. And now we can still get the AI that Richard wants, where everybody has access to AI, but we can also get the transparency and trust that Dr. Ruchi wants, because you can have a more experienced surgeon looking at the data in real time, even if they're not able to be there. I mean, in dentistry, the big change for Invisalign became a $1 billion company was they want to allow general practitioners to do orthodontics, a more complex or very specialized way. They democratize more complex dentistry. Imagine if we can do that. Imagine if we can democratize surgery by helping more general surgeons, more or less trained surgeons do better, because we can give them, using AI and using access to more experienced surgeons, we can give them better access to technology. And that's where you get scale. Of course, technology has to be cheap. It has to be mobile. It has to be scalable manufacturing. At the big scale, the one thing that's harder to duplicate is Dr. Sharma experience. As you said, he learned for 15, 20 years, and Dr. Swapnil, the same thing. These guys learned for 15, 20 years, became experts, took them another 100 or 500 or 1,000 surgeries to be real leaders in their community. How do you duplicate Dr. Sharma? That's the promise of AI. That's the promise of technology. Not to make a $500,000 system cost $50,000.
Yeah.
So to duplicate that.
So probably your vision is that, yes, because the technology is in such a nascent stage, probably it will be an interesting efficiency improving tool for the elite now. But 5 years down the line, when the cost becomes reasonable, it will be available to the masses, to the billions of people in different parts of the world, and then it will become accessible to almost everybody. Okay. Now, with that, let me take insights from Dr. Amit Sharma, because you are living in South Mumbai, some of the best hospitals of India, and I'm sure that you are treating movie stars or billionaires of India. How do you look at this question? What is your insight on this?
So, Pankaj, so it's coming back to your question was whether it should be scalable and available at like all the different centers, even in the second and third tier cities of India, or should it remain at elite centers? So, in an ideal world, we would like all the technology available at all the places, but the matter of fact is that it's not possible. So you go back to, like, you remove the AI part. We have seen that in these smaller cities, patients get treated, but whenever there is a complicated case, whenever there is some extra expertise is required, whenever some extra experience is required, patients are referred to bigger cities. I think same is going to happen to some extent with the AI also. So AI also, I'm sure, will have some different gradations, like so for me as a doctor, there are three important things whenever I need to treat a patient. One is a diagnosis. I need to make a correct diagnosis. The second is I need to know the correct treatment for that particular diagnosis. And the third is that treatment should be executed in a perfect possible fashion. Now, diagnostic part, yes, like as we spoke, radiology is kind of, and maybe tomorrow we might come up with some, algorithmic patient questionnaire. Patient will fill out the form, and then AI will tell us, okay, the patient is suffering from this. When it comes to decision making, maybe we click a picture of MRI. There's a lot of confusion whether we need to fuse only L4-5 or we need to go to L3-4 also or L5-S1 also. What to do about the cervical spine, which is also affected. So maybe we click a picture, we feed in the patient's clinical history and examination detail, and then AI can give us the answer that, okay, this is what is required to be done. So that's the decision making part. And the third, the execution part. So I need to do the surgery, I need to do the decompression. Like for me as a spine surgeon, I need to do the decompression and I need to do the fusion. So in decompression, how extensive do I need to go? AI might help me. Okay, in this case, you do microdiscectomy, like a small keyhole procedure. No, this case is not perfect for that. You do a wide laminectomy, multi-level. Or maybe this case requires instrumentation at this particular level. And then while executing this, it is helping me, it is guiding me to go in the direction I need to go. Now, all these models of AI, which will help you in diagnosis, decision making, plus execution of your treatment. I'm sure they will have it's like you buy a software and it has different categories of subscription, and each subscription there will be premium, there will be super premium, and they will come with the different categories of features they will be offering to you.
Yeah.
So I think this gradation will, to some extent, will always remain between, and this will come in our way of scalability, because everything will come with a cost.
Yeah.
Not only the cost, but maintenance cost also. So whatever you try in terms of scalability, to some extent, I think this gradation will always remain. And I mean, as I said, in an ideal case scenario, we would like to make everything available at every place. Yeah. But in the real
not
world,
practically possible.
Not possible.
Yeah. Okay.
So yes, if you want to take my opinion, then yes, everything should be like this. High-end robotics should be available in the Nanded to every surgeon who is one of my fellow is working in Nanded now.
Yeah.
It should be available to him, but it's not possible. So
because we are talking about Nanded, let me take insights from Dr. Swapnil as well. His journey has been from New York to Nanded, and that's the real tier 2, tier 3 city of India, right? How do you make these kind of innovations accessible in smaller cities of India or Africa or South America? What can you do? Dr. Swapnil, please.
Yeah, it's possible to scale. Use these devices in smaller cities. The biggest problem I would see is the cost. If somehow cost goes down, then yeah, this device is. Orthopedic surgeons, neurosurgeons, spine surgeons, they will buy this device. Yeah. Somehow, the manufacturers, ours or Richard, they can work on that. Yeah, to decrease the price. Yeah, definitely, it's scalable and it's useful. I would say it's a useful device. Yeah.
So and if not if cost cannot be reduced because of obvious reasons, then there has to be some political will, some support from the government organizations, grants and things of that nature, right? Awesome. Now my next question is around balancing act, right? Obviously you want to do innovation, you want to bring innovation to different cities, countries, but then there's also liability associated with that innovation. You have to assess all kind of risk associated with the new innovation. You have to create the risk mitigation plan. You have to win patient trust as well whenever you are utilizing that highly innovative solution on a patient. And then obviously you have to be completely aligned with regulatory bodies. You have to be compliant and so on and so forth. How do you achieve that extremely difficult, complicated balance as a hospital or as a healthcare innovator? And I'll take Dr. Ruchi and Richard's feedback on this. First, Richard, because I know that you have been with the medical device innovators in the past, and you sold the solution. So please go ahead.
Well, I still am. So we both do upstream and downstream, and upstream is the R&D part, and the downstream is the execution. So a little bit on that part. When I was like 30 years old when I was head of Europe, Middle East, and Africa. I'm 33 when I was head of global. So I've earned my keep on that part. But I've also am fully aware that we've just seen the beginning of what policy can do. So I was involved in 2024 with the EU AI Act, and I was very humble to give a presentation on that with I think the chair of the legal council of Takeda. And Takeda is a pharmaceutical, $27 billion pharmaceutical, on the EU AI Act in Europe. And I think we have a three-way law on policy, where an AI, so a little bit on the US and the EU balancing act on that part, as long as it's not infringing within the body, so that's very much similar to the medical device guidelines, you have a class 3 AI tool. But for any lawyer that may be looking, and I'm quite sure there will be a couple of lawyers looking into this session today, the definition of AI in that policy rule book isn't clear. So that's still open for debate, because what's an AI? So from a legal point of view, it would be a tough nightmare, and I would be looking forward with excitement to that first legal battle. It will not be into effect in 2026. So I think it will be around the terms and definition. But I think ultimately, as decision makers, and this is where I am lobbying for in getting products to certain ecosystems in that sense, we should always argue, if we do it, what's the risk of doing it? What's the risk of not doing it?
Right.
And if you can make better decisions for the people at hand with an AI algorithm by lack of any means, and to Dr. Swapnil's point on scalability, because it's an interesting point. If you can give people 3 years or 4 years of extra life because you're able to detect it earlier on, and they're able to earn an income for their family for 3 or 4 years, times 30K times 4, it's 120. And that would be in line with and that's why I'm doing a bit of policy, because I think my arguments are very solid. You would give them some extra bandwidth to take care of that ecosystem And in that way, you can raise everybody a little bit, and because then you can treat patients with relative low-cost drugs like statins. And I think from that point of view, we should be, and I call it clubbing it to death of modern technology, because we all live in a world of finite resources. But I think making best use of autonomous decision-making support and making our yeses and nos better, well, we would be scaling technology, I think, to places where it's needed most. And we call it digital self-care intervention. So that's the term, but we argue still a bit about the term.
So you are championing the AI systems.
Whatever it takes.
To the policymakers. Okay, interesting.
Yeah.
That's good.
Yeah.
Dr. Ruchi?
So one thing I have to say that we're probably digressing to the usefulness of AI rather than talking about surgical AI, right? I am all for AI and I'm all for the usefulness of AI. I call myself a digital health champion. It's only because I believe in these technologies. I worked with World Bank and IFC in some of the remotest part of the world, India, Brazil, East Africa, bringing in technologies from the world and basically giving doctors or carers where, skilled professionals are not possible. So from a public health lens, if you look at AI definitely has value.
Right.
There's no debate on it. But when you talk about, your last question was about the uptake of it. When stethoscope was invented? Around 1821, right? It took doctors 25 years to actually adopt it. The questions were around, it looks awkward, percussion and bedside history was enough. Why have another device for this? Then, several other, and then it looked awkward. It was a little different, and then it remodeled. I think it's the same with AI and everything else, because healthcare has always been an ecosystem play. In silos, innovations don't work in healthcare. And that's why when you look at surgical AI, you have to keep in regard the insurer, the patient, the law, the governance, everything. So when you look at all of these things, from the lens of whether it can practically work or what you call that democratize, it looks still difficult because there are so many things. And first of all, it is good to see that, the onus from doctors and institutions are now shifting into a hybrid model where there is a certain, onus on doctors for clinical negligence, but then there is an onus on institutions as well in terms of their governance or the skills. And then there is a manufacturer ones, whether it is how they defined the AI and the algorithm to the post-market updates, which is a great thing, which is the thing that we are moving into. I still don't feel that, for surgical AI specifically, where you're operating on somebody and you know that the onus is going to land on either the institution or the product or the physician, it is safe to make it purely autonomous. Because I think what we are struggling here from a policy level or from this panel discussion or otherwise, operation room discussions is how to make it responsible and accountable enough so that we know who is the supervising physician, who can override, who is responsible. And when the M&M discussion then happens, then we get to know the failures and then we act accordingly. It's like defining where the responsibility lies. Because the one question that we are not comfortable with is, I don't know, or nobody knows what happened, right? So I think that's what we are kind of fearing. And to balance the trust, the question that you asked, there are several things you can do. You can have an AI governing council within a body where there is a pre-op, then there is a surgeon, then there is a M&M member, and then there is somebody from the product side. And together you create a governing council. You keep certain methods and metrics in check, and you meet, and you go over it over and over again. That could be one. The other one that I probably wrote about is if you want to reach scale, you need to first prove productivity. Most of the time I have seen AI models talking about console time, but productivity is not just console time. It is before the console time, which is setup, and after the console time, which is closure. So if you can prove productivity across all these three steps, then you can prove the economic benefit of that solution. The other thing is total cost of care, which basically means the stay plus 90 days. So as a business person, I amortize every device for every case. to come on to a certain level in terms of economic numbers, whether it works for the hospital or not. So I think these are some of the measures by which you balance trust of, I mentioned about the Montgomery law where you even disclose it to the patient, the ATRS in terms of building transparency around what is happening, and constantly making a very responsible atmosphere where humans and AI can act together.
Interesting. So a couple of key takeaways from the overall conversation, right? The human and AI will have to work together. However, the accountability, the responsibility, the authority has to be with the surgeons, right? It has to be scalable. It has to provide the clear ROI, clear value proposition, quantified value proposition, and productivity to the hospital, and obviously for the patients as well, and as well to the insurance companies. These systems will have to win the trust of patients. Without that, you can't really adopt these innovative solutions. And most importantly, we need to think about how to optimize cost to make these things extremely scalable and accessible to all the different countries and cities of the world. I think this has been a very fantastic, enriching conversation so far. Again, I really want to appreciate all the panelists for this amazing, insightful conversation. And now we will transition a bit from this enriching conversation to understanding how Erez, CEO and founder of Pathkeeper, is actually bringing innovation in the spine surgery space. He will present a few slides, and then we will have probably a few questions for Erez. And I would request our panelists to be extremely direct and brutal while asking questions to Erez. So he's not getting a sugar-coated BS, but he's getting the actual brutal feedback from the experts on the field. Erez, please go ahead.
Thank you, Pankaj. So basically, when we started to work on Pathkeeper, we wanted to help spine surgeons do better. Of course, the goal is that spine will be just the first, but we believe spine has significant, unique risks. And as Dr. SHARMA says, the main goal here is to put screws more accurately. If you miss a bit, you touch a nerve cord or it breaks, it's very bad. And specifically looking at the cervical, there's not a lot of room for error there. Surgeons doesn't have a good visibility. They don't see like we see it here, right? They see that's even a better visuality than in real life, because in real life you have blood and everything. So how do we make sure surgeons that has poor visibility hit screws every time? If you look at the research, 30% of the screws are misplaced, and there are revision surgeries, and the cost for revision surgery is huge, and we know that. So as a surgeon here said, today the common way is to use X-ray. Take a 2D X-ray or fluoroscopy in real time, or a 3D X-ray, $1 million machines, but this is a lot of X-ray. And X-ray hurts the patients, hurts the surgeons. So that's a very bad way to balance between the patient clinical outcome and the surgeon and surgical staff health. In addition, those technologies are very expensive and they're very limited, because if something starts to move during surgery, you have to take another X-ray and another X-ray and another X-ray. If it's a 3D X-ray, it's a 10, 15 minutes process. And that's why it's not a big risk. That's why very few hospitals use it. And that's why Dr. SHARMA said this is an expensive gadget. It's a great concept. It's passing the right way, but it's not exactly there. So we wanted to develop a system that uses 3D optical imaging, which is my personal background, eliminates the radiation from the surgery, stay compact and affordable. So we really want to be able to have every small hospital afford that. Because in the end, it's a camera that we develop, but it's a camera and a computer system. It's not expensive. It's not crazy amount of money. It has to have real-time precision backed by AI. It has to be more trustworthy. and efficient than anything else out there to justify that. And spine is just the beginning. It has to be a technology that can grow beyond spine to general orthopedics, to neurosurgery, and maybe even beyond that, cardiac and other stuff. So how do we do that? The first thing we did is build a very high resolution 3D camera that is suitable for the surgery. We're using infrared, not because it's nice, but because there's a lot of light, a lot of shiny objects in the surgery. We want to eliminate them, and the resolution has to be very, very high. We want to be hardware agnostic, so keeping the cost down, keeping the surgeon's decision easy. And we want to bring this anatomical AI, the measurement. And as Dr. Ruchi said, the clinician is responsible. So my solution for trust is transparency. I want to show the surgeon what's happening, what the AI thinks, what's the analysis, and the surgeon can always make sure that the AI got it right. Because yeah, it can get it wrong. That's just technology. And of course, a low-cost, portable solution that's compact. When you start using real-time imaging or optical imaging in the surgery room, you can start getting additional capabilities. I just put here a few capabilities that the AI can do, are very hard for humans to do. Here below, for example, one of the risks in spinal surgery is wrong level surgery. Those vertebrae are very similar to each other. And surgeons have to take very meticulous care to make sure that they work on the right vertebra. The AI can measure stuff very, very accurately and eliminate the clinical, the cognitive burden, the time, the extra x-rays that are needed to make sure that the surgeon is actually working on the right vertebra. With AI, it's a few second operation. We talked about, being focused. If the surgeon is a bit out of the way, the AI will tell the surgeon they are going to hit the cortical bone soon. And as I said, very, very important, start measuring things in real time. Spinal surgery is all about deformity correction, placing the vertebra in the right physical position to minimize stress and therefore minimize revision surgery. Surgeons today have to estimate, intuitively guess the angles between those end plates that they can't really see. The AI can do those real-time geometrical measurements very, very easily, show the results, make sure the surgeon understands how the AI got to the data, and show very actionable data for the surgeons in real time. So we are now doing spine. We are already in the market in the United States with FDA clearance. But that's not enough. I mean, as I said, I think PathKeeper can extend the technology further. We're developing a miniature 3D camera, which is 1/2 inch in diameter and can go to doing A-lifts, doing endoscopy. Imagine navigated endoscopy where you can really know where you are in the body, integrated with MRI or CT previous scan. And we will add knees and joints and cranial surgery, basically creating a full platform that is AI-based, very efficient, very low cost, and as we grow, prices can go down and really help everybody anywhere. Be happy to answer any questions.
Fantastic. So that was the quick overview of PathKeeper from Erez. And as I said earlier, he's ready for brutal questions. I see Dr. Ruchi has...
Yeah, I have one question. Thank you for the presentation. This is great. Can you tell us how diverse your training data sets were? I mean, in terms of patient demographics, spinal pathologies, operating environment, and have you validated your optical AI system across different types of ethnicities, given that reflectivity and skin tone can also affect depth perception?
Right. So regarding your last question, we are tracking the bones. Mm-hmm. So I'm not familiar with color differences in bones of different ethnicities. Sorry. Our data set is very varied. We got it from hospitals and from public data sets all around the world. I don't have clear statistics, but again, very diversified. Very important for me was to have different CT scanners, for example. And not just using high-end GE machines, but using every type of technology out there So from the technology-wise, it's very varied. And one of the things that is still in development and still growing is the actual surgeons working with the system database. And that's part of ongoing work. Every case that we do, we have an extra point in our database that goes into the engineers to keep improving the algorithms. And every few months, we can come up with a new verified and tested version. So we have done surgeries on pediatrics, 3 years old and 80-year-old people. We have done different sizes, different types of people. And so I think we've been able to prove technology is relatively general. But as we talked during the conference, it's always about giving the data to the surgeon and having the surgeons make the decisions. It's always about that.
So 2 more questions, just out of curiosity. One is, how do you convey uncertainty to the doctors, to the surgeon?
Right. So we show the surgeon the system algorithms. We show how the optical AI matches with the 3D. We show quality numbers. So for example, we show the level of accuracy of the surfaces. I don't know if we have time, but I can maybe share with you a video later of the system operating, and then you can really see the match. And you can see where there's a good match, where there's a bad match. And there's always measurement. There's always feedback to the surgeon how accurate it is. So the surgeons will touch, for example, in the verification stage, will touch clear anatomical landmarks. And the surgeon can tell by themselves if it's accurate or not, but also the AI will say, this is good, this is bad, and you probably have to add more data for the AI to improve the algorithm. This might be good, might be bad, please consider and add more data or not, depending on your decision. So we keep the surgeon in the loop all the time.
No, thank you so much. This is really impressive. And we have a similar background is what I realized. I'm also a dentist. I am a trained private pilot. I've worked in aviation for a bit. So yeah, it's a small world. Thank you for your presentation.
That's quite interesting. Thanks a lot, Dr. Ruchi. Other questions from, please go ahead.
So, there are concerns whenever we are using navigation. One, the patient is subjected to a preoperative or intraoperative radiographic data collection, either by doing a CT scan or by doing O-arm spin or maybe a 3D C-arm spin to collect that data to feed the computer, and based on that it will create that bone model which will be later utilized by the computer to guide us to put the pedicle screw. Exactly. So that's about one factor which most of the surgeons have in their mind, because you said that there's a lot of radiation when you are going to put the pedicle screws freehand as compared to navigation based. But this radiation is, maybe the surgeon is out of the picture when the O-arm spin or that C-arm spin is being taken place, but the patient is definitely being subjected to it. Today only I met one of the C-arm guy from Germany. He said there is about 320 C-arm shoots are taken to register the data for one, to convert it into a so that they can do the navigation. So what is your opinion about that? And the second question is these markers, markers are placed not at the level where you are operating, because spine is a mobile structure. So marker is placed maybe in the iliac wing, which is like 2-3 levels down. There are multiple discs in between. And what about that movement which is happening in the disc in between, which can actually put you off track while you are actually inserting the screw based on the data which is provided by that marker which is on the iliac crest. So what are your thoughts about these 2 points?
Right. I completely agree with the second part. I agree with both of them. But for the second question, I have perfect answer for you. Because the pathkeeper system is an optical system. It means we have a 3D camera that take a picture of the anatomy directly. So yes, we have the reference array, but if the reference array is on the ilium and you're walking on L3, I'll take a picture of L3 and register L3 just before you put the screws. And that's why I can guarantee that it doesn't matter how much a disc moves, you are perfectly accurate. And if you're not sure, take another 3D scan. It's just 5 seconds, no radiation. So it's almost as quick. I mean, from my perspective, every time that you give to your system to put a screw, take another 3D optical scan. It's few seconds, and you're guaranteed to be accurate. Even during the case, even during putting the screws in, you bump the table, somebody moves the reference array. I don't mind. Take another optical scan, and it will be accurate again. That's why we've been able to prove to the FDA that we have sub-millimeter accuracy in this registration and implementation part, because we can track the anatomy in real time. So I think that's, Pat Keeper, solve your second questions completely. Regarding the first questions, I think long-term, we really want to have MRI-based navigation. There are some companies working on that. We are partnering with them, and I think that's where it goes. Short-term, we are working with Mayo Clinic on low-dosage CT scan. So CTs are more efficient than OR regarding radiation perspective and accuracy. By working with low dosage and starting to increase the low dosage, we can be in a situation where it's not 300 X-rays, it's less, and still it's good enough. Again, using AI augmentation, it is becoming good enough for the navigation. So the Mayo Clinic Pediatrics group really working with us on minimizing the pre-op radiation for CT. And because of my answer for question 2, you don't need to take another scan in the surgery room, even if things move. Even if it's a complex deformity case for pediatrics, we track each and every vertebra separately. So no need to take 3D scans in the surgery room, low dosage CT, and in the future, full MRI scans. That's how I see it goes.
Thank you, Erez. Do we have questions from Richard or Dr. Swapnil?
I'm good. Thank you.
Thank you.
Same here.
Okay. Or if any guidance, any insights for Erez on the product roadmap, on the go-to-market strategies?
Yes, but I think we already touched base a bit on that. So I've been, obviously, I've been working in the dental field for quite a while. So I know your product quite well from an image sensory point of view. But I have nothing to add at this moment. But I think for a speedy uptake, 2 points is a line, 3 points is a surface. And if you shift that surface and to prevent rescanning during procedure, on how to overcome that, and I think your go-to-market business model, because I'm an economist, but you probably are good with numbers as well. So thanks so much for that. No questions at this moment. Not on LinkedIn Live. You're good.
Thanks a lot, everybody. Really appreciate your time today. It's very difficult to get an hour from surgeons' schedules. Really appreciate that. And I'm sure that we will have side conversations and do a deeper dive into how we can support each other with different initiatives, different objectives. So really appreciate your time today. And I hope that we reconnect later and explore some issues.
Thanks, Erez. All the best.
Honor to meet you, everybody. Thank you, guys.
Thank you so much for the time. Thank you, Rich. Bye.
Bye.